Alright guys, welcome back to geometry. Today is 7/22, and today we're taking a look at midpoint and distance. Okay. Now some of this is going to be reviewed from Algebra 1, but first I'm going to do the part that's geometry that relates to what we did yesterday. So we went over the homework from yesterday, and hopefully you got a good feel for how these problems work, where you've got a point in the middle of two other points. But here, let's go ahead and take a look. First, let's define a midpoint. So we're going to let A, B, and C be collinear points. Right? If that's the case, we say B is the midpoint of segment AC if and only if, that's if with two F's, AB is equal to BC. Alright, so the distance from A to B is equal to the distance from B to C. Now here, this if and only if means we can read this statement two ways, right? We can read it as if AB equals BC, then B is the midpoint of AC. Or we can read it as if B is the midpoint of AC, then AB equals BC. Okay? That's what's cool about this if and only if statement, where you write if with two F's. And again, this only works if A, B, and C are collinear. Okay? So here, what we're going to see is we'll see a couple different problems, right? Right? And here, we'll be told A, B, and C. If B is the midpoint, the first thing we want to do is we want to update our picture. And the way we do that is we're going to show that segment AB is congruent to segment BC. So here, AB is congruent to BC. So we just put those little tick marks on the line, letting us know that they're congruent. So there's two statements here. The distance from A to B is equal to the distance from B to C is the same thing as saying segment AB is congruent to segment BC. Okay, so notice when it's a congruency symbol, we're talking about the segments, so we need the segment symbol. When it's an equal symbol, we're talking about just the distances between the endpoints. Okay, so again, equal sign, congruency sign. Congruency just means same measure. Okay, so here, this is fairly straightforward. If I told you that this was 7, right, you could tell me that the whole thing is 14, because this side would also have to be 7, right? Likewise, if I told you that, hey, this was 9, then you could tell me that each side would be 9 halves. Okay, so that's what distance and midpoint do for us, is they allow us to go ahead and know that the two sides are going to be the same. Okay, so you can imagine some problems like we did last night. I'm not going to show them to you, but just know with a midpoint problem, the two sides are congruent. Yesterday we took a look at where just a point was in the middle, so we're able to do segment addition postulate. Tonight you're going to see some problems where we know that that point is the midpoint, so the two sides have to be congruent. All right. We're also going to be taking a look today at some coordinate geometry with midpoint and distance formula. Okay, so coordinate geometry is similar to what you've seen in Algebra 1. You've already done some of this, right? Coordinate geometry essentially takes the points, the lines, the segments and everything, and just moves them onto the coordinate plane, okay? So now when we talk about points, those points will have coordinates, right? So we're going to let A have coordinates, and we'll just go with x1, y1 for now, right? So it's an x with a little subscript 1, y with a little subscript 1. And we're going to let B have coordinates x2, y2. Okay. Now, if that's the case, then we can define a midpoint, right? So the midpoint, we'll call it M, will have coordinates x1 plus x2 over 2 for the x coordinate, and the y coordinate will be y1 plus y2 over 2. Okay, so that's going to be our midpoint formula. Now our distance formula, I like to use a slightly different notation than you're probably used to, because I'm actually okay with you doing distance formula in your head. Okay, distance formula is really just the other side of Pythagorean theorem, right? There's two sides of the same pancake, right? So we know the Pythagorean theorem says something like a squared plus b squared equals c squared, right? So here, if we think about 2 points in the coordinate plane, right, they kind of make a right triangle, right? This side would be C, this side would be A, and this side would be B, okay? So what is A really? Well, A is the difference between the two x values. It's the horizontal distance. So it's this delta x value, right? And B is the change in the vertical position, the change in height. So it's kind of our delta y value, right? So now we can rewrite our formula and say, well, hey, this is going to be delta x squared plus delta y squared equals c squared. And then since that represents the distance between the 2 points, or the length of the segment there, I take the square root of each side, and voila, I have my distance formula. So for me, the distance formula is going to be delta x squared plus delta y squared, and then take the square root. Okay, so make sure you're following the order of operations on that. Okay, the one you saw in Algebra 1 probably looks like this, right? Because to find the distance between two x values, we just subtract them. So x2 minus x1 squared plus y2 minus y1 squared. Okay, so again, you may have seen this formula in Algebra 1. This is the one I'm going to reference in geometry here, right? Delta x, delta y. Okay, so let's see if we can't take a look at some example problems where we might apply this, right? I'm just going to go ahead and give you some points, and we're going to go ahead and do some distance and midpoint. So here, let's go ahead and say A has coordinates 3, negative 4, right? We'll say that B has coordinates negative 1, and we'll go with negative 1 and negative 1. Why not, right? We'll get crazy with it. And let's say that C has coordinates 5, 7. Okay. So here, we can do a few things, right? The first thing I can actually do is I can actually find the midpoint of AB. Okay. So if I want to find the midpoint of AB, right, if it helps you, you can mark these, right? So for this problem, that would make this, it doesn't matter, let's go with x1, y1, and x2, y2. So remember, for midpoint, you just want to think average, right? You just want to take the average. So where's this x value on average? Well, 3 plus negative 1 divided by 2. And then here, where's this y value on average? Negative 4 plus negative 1 divided by 2. That will give me the coordinates of my midpoint. So in this case, 3 plus negative 1 is 2, divided by 2 is 1. Negative 4 plus negative 1 is negative 5, divided by 2 is negative 5 halves. So there's my midpoint, 1, negative 5 halves. That is the midpoint of AB. All right. Now I go ahead, I can do the midpoint of BC, I could do AC, it doesn't matter, but this in general is how midpoint works. You add the two x values, divide by 2, you add the two y values, divide by 2. Okay? It's the average of the x, the average of the y. All right. So midpoint's pretty easy. All right. Now, what's hard is if somebody tells you a different problem like this, right? Say C is the midpoint of segment BD. What are the coordinates of D? Okay. Now, we can do this algebraically, and we can write a formula, we can solve it, but this one's actually going to be a little bit easier if we just use a little bit of common sense here, all right? So what I'm going to do is I'm just going to make a segment, any segment, right? It doesn't have to be drawn on scale, it doesn't have to be correct, right? I'm going to put a midpoint there in the middle, okay? Now here, I'll label one of these B, I'll label one of these D, right? Because that's the endpoints of the segment, and C is going to be in the middle, all right? Now let's put our coordinates, okay? B has coordinates negative 1, negative 1. All right. C has coordinates 5, 7. D has coordinates I don't know. All right, so that's what we need to find. Well, it has to be the same distance from C to B as it is from C to D, just in the opposite direction. So how far is it from 5 to -1? Well, that's 6 this way. So that means I'm going to have to go 6 that way. Well, 5 plus 6 gives me 11. Now we're going to do it with the y values. All right. 7 to -1, right? We do 7 to -1. That's going to be 8 spaces to the left, which means this one has to be 8 spaces to the right. 7 plus 8 is 15. So I know that the coordinates of D are going to be 11, 15. That problem might be worth a second watch. All right, that's how I like to do them. That's the quickest way to do them. There is a longer, more involved way with a formula. If you want that way, please email me. I'll be happy to show it to you, okay? All right, so that's midpoint, all right? Not too bad. Now we can take a look at distance, right? So here we'll just find AB, okay? Let's find AB, all right? So I know this is going to be distance formula. When I'm doing distance formula, I like to go ahead and set up my shell for my equation, right? So I know it's going to be square root of something squared plus something squared, okay? Now here, remember, I talked to you about this idea of delta x. How far is it from 3 to -1 on a number line? Well, they're 4 spaces apart. So that's my delta x, right? And then how far is it from -4 to -1 on a number line? Well, that's 3 spaces apart, okay? Now you'll notice I'm not worried about the sign. The reason I'm not worried about the sign is because when I square it, it's going to become positive anyway, right? 4 squared is 16. -4 squared still would have been 16, right? So that's why I'm not worried about the sign, right? 3 squared is 9, right? I did square root of those two. 16 and 9 makes 25. And the square root of 25 is 5. So I know that AB is equal to 5, all right? Now I could also ask you to find a different one, right? We could do find AC. No problem, same thing, right? So we go ahead and say AC, set up my shell, right? Something squared plus something squared. Now it's going to take a look at our x values. How far is it from 3 to 5? It's 2 spaces apart. All right, now the y values. How far is it from -4 to 7? That's a big one, it's 11. Okay, so now here 2 squared is 4. 11 squared is 121. 4 and 121 is 125. So this is going to be the square root of 125. Now I don't want you to use a calculator for this. Please do not use a calculator for this. What I want you to do is I just want you to stop here. If it's not a perfect square, stop here. Later on in the year, we're going to learn that this actually is equal to 5 root 5. And we're going to talk about that later, all right? But for now, you're just going to tell me it's the square root of 125. Okay, that's a more precise answer with that round, all right? So that's a review of distance and midpoint, as well as midpoint as it relates to diagrams in, I guess, what we would call Euclidean geometry. All right, so if you have any questions, please email me. I'll be happy to go over this with you again. Make sure you understand it.